Well, welcome. It's going to take a couple minutes for all the attendees to come in when I open it up. So I'll give people a minute. If you want to grab a coffee or something, this is the last chance to do that. Wait until the attendees start to level off. Let's see. Now this is a webinar, so we're not allowing people to turn on their cameras or their microphones. So if you have any questions, you'll have to enter them through the chat and be a little patient, because I'll be teaching and looking at the chat. If you can see the chat, maybe say where you're coming from. So hello from Toronto is what I'm going to put in there. And just note that you can send the note to everyone or just to the hosts and panelists, which is really just myself. But if you send it to everyone, then we get a sense of where people are coming from. Denver, Huntington Beach, Laguna, Buffalo, San Francisco, all over the place. Pittsburgh, Durham, North Carolina, Ottawa. So I think there's a few more people still coming in, so I'll give it a little bit more time. This session will be recorded, so we'll be sending you the recording of it. We'll send it to everybody who registered. You know, we probably get about 30 to 40% people actually attend, but you know, a lot of people just sign up and hope to get the recording. So this one, you will get a recording within, you know, a couple of business days. And looks like the number of attendees is starting to level out. So I'm going to get started. My name is Miles Brown. I work for a company called ExitCertified. We've been an IT training company for over 20 years. I've been here sort of on and off for about 20 years. I contracted for a while, and then I did some other stuff, but I keep coming back to teaching. And I'd say for the last, I guess, 9 years, I've been teaching a lot of cloud. These days, I don't teach day to day. You know, I do a lot of helping our salespeople when they get into sort of technical discussions with customers, trying to figure out what's the right plan. Because ExitCertified is, we're partnered with all the major cloud vendors, but probably about 25 plus vendors like, you know, like IBM and VMware, as well as all the major cloud vendors. And so, you know, we have a wide array of IT training, and a lot of times we end up building training plans that go across vendors. And so that, you know, we really need to talk to technical people to find out exactly what they're doing and what they want to do. So I do a lot of that sort of, you know, pre-sales type stuff these days, but I still teach. I'm an authorized AWS instructor and Google Cloud and Oracle Cloud. I do not have my Azure certifications, although I've taken the courses and I've got some of the knowledge. I never bothered to get those, but I think I'm well suited to deliver this webinar. You see the title there is Public Cloud Comparison 2023. I'm going to concentrate on these 4 vendors because they make up the bulk of the North American market. They are not necessarily the 4 largest, because there are 2 from China that are very large. But in North America, these are the main cloud vendors that we talk about. And this is a little bit of an outline of what we're going to look at over the next hour. We'll talk about models of cloud services, and then we'll get into what kind of workloads are people doing in the cloud, and then we'll get down to business, and we'll really get into, let's compare those 4 public cloud providers, look at where they came from, and what's the case for each. You know, why would somebody pick AWS? Why would somebody pick Azure? Why would somebody, you know? And then we'll talk a little bit about hybrid and multi-cloud and how that's becoming an important thing. And we'll end off talking a little bit about, you know, what we do at ExitCertified, which is, you know, cloud training. There should be time for questions at the end, but all the way along, if you have a burning question, you can throw it in the chat. I will try and keep an eye on it at various points throughout, but let's jump right in. So when we talk about models of cloud services, you probably heard people talk about infrastructure as a service, platform as a service. Sometimes they call that PaaS. So let's just get an idea of what we mean by this. If you were to run your own compute resources in your own data center, you know, sort of on premises, that's what we call, you know, traditional data center, where you basically set up a network, and you get racks full of servers and some storage, and you're in charge of everything, right? But it gives you the most control over exactly what runs. But there are some definitely implications about, well, you have to buy a bunch of hardware up front and pay for it up front, right? When the cloud came out, really, we're looking at about 2006 is when AWS came out, and that sort of started people to think about this idea of, well, what if I let somebody else take care of my data center? Now, people have been doing that, right? There's this sort of co-location, where you rent cage space in somebody's data center, but it's still, sort of you're doing the stuff. AWS kind of opened up a whole new market where they said, no, we'll take care of the hardware, the virtualization, everything. And so you basically come and rent a virtual machine from us. So everything up to the installation of the OS we'll take care of. So you never have to think about hardware again, right? All you have to do is take that operating system, harden it, patch it, and then install whatever software on top, and patch that and everything else. And so that's what really these days we call infrastructure as a service. It's where you're generally renting VMs for, pennies an hour, basically. But you probably also heard of software as a service if you've used anything like, I don't know, Gmail or Salesforce or anything like that, where you don't really think about even the software, right? It's all built and given to you, and they hold your data somehow, but they're also controlling that and storing that and securing it. And really, it's just an application that I use over the web, right? And in between, we have this other one, platform as a service. And what we find is that that's where the public cloud providers have really added a lot of services. And so you're just sort of moving up that level of, who's in charge of managing what we're running in that data center. Well, not only is that cloud vendor in charge of the physical hardware and the virtualization software, but also the operating system and the application installed. So a best example of it is something like a database, right? Where I don't even have to install the database and do the basic DBA tasks. Even those are taken care of by my cloud vendor. And so when we look at the public cloud, they really focus on infrastructure as a service and platform as a service. Now, all the public cloud vendors have some software as a service type stuff. I mentioned, Gmail, but things like Office 365, but even other tools like Dropbox, Salesforce.com, those are all examples of software as a service. All the cloud vendors have some of those things too, but that's not their bread and butter, other than Microsoft, where Office 365 is, big part of where they make their money. But if we look at something like platform as a service, that's the one for a lot of people who are new to the cloud that is the misunderstood. And I use the example of a database. So if we look at AWS, they have a service called RDS, Relational Database Service. And they said, basically, for these 6 different database engines, we'll be your DBA, right? We'll take care of the basic installation of the operating system and patching of that, installation of the database and patching of that. But we'll also set up nightly backups. If you want to set up 2 different databases for high availability and one dies, we'll fail over to the other. We'll take care of all that. You don't need to understand how to set up replication in Oracle. We'll do that for you, right? So it really takes a lot off your plate. But of course, there's always a trade-off there, right? You're saying, okay, well, I don't have to do the DBA work. I'm allowing some brainless algorithm at Amazon to do it. That's an interesting trade-off, one that I might not like. Well, you don't have to take it, right? You can still just get a basic VM, install your database, and take another VM somewhere else and install it there, set up replication, do all the work yourself if you want to control exactly how it's done. But for a lot of organizations that are a little leaner on the operations side, very developer-centric, this is very attractive, right? But in the end, you're not really the DBA, right? You get a JDBC or an ODBC connection, you connect to the database, you send your queries, you set up your tables, right? You're still doing the DBA tasks of, hey, where should I put indexes and how should I set up partitioning, things like that. but the low level, take backups, set up, replication, all that stuff is done for you. And AWS isn't alone in this. All the cloud vendors have those kinds of platform as a service for at least some databases. Another example of a platform as a service is in Azure. They have Azure App Service. Obviously, Azure is very good place to run things if you're very much a Microsoft shop. So especially if all your development is in .NET, you can take a nice zipped up .NET app and say, hey, this is a web app. I want to run this in a very scalable way. And I don't want to have to think about how many VMs am I going to be running? And what if one dies? I need to replace it. They take care of the auto scaling, the high availability. You say, here's my GitHub repository. Go take that code and get it into production in a nice scalable way and take care of all those things for me, right? So all the different cloud vendors have those kinds of ideas. And so, just to go back a level, that platform as a service and infrastructure as a service, that's mainly where the cloud vendors play, right? But there is sort of a newer term that we didn't cover in these four. The newest one is sort of this idea of function as a service, right? Some people call it serverless compute. I've even seen it called FPaaS, like a function platform as a service. In AWS, we've got Lambda. That was sort of the big one that it's very popular. But Azure has Azure Functions, Google Cloud Functions, Oracle has OCI Functions. They're all very similar concepts where it's very, very developer-centric. And you say, I don't want to worry my pretty little head about where is this code going to run? How is it going to run if there's errors or anything? All I want to do is configure what's the event that causes this code to trigger, to fire. And I'll pay, in 1 millisecond increments for how long the code runs. And it's very good for things where, hey, there's periods of inactivity and then all of a sudden it's busy. I don't have to worry about, well, how many VMs should I be running? I don't think about VMs at all. I just say, here's my code, here's what causes it to fire, right? And so the big idea of serverless, it's a bit of a misnomer, right? There are servers there, but I'm not worrying about them. My cloud vendor's worrying about them. And so for some people, this is a very attractive way to jump into the cloud. Now, this isn't going to work very well if your plan is to take existing apps and just sort of lift and shift them into the cloud, because you're going to have to totally redesign it to be event-driven and use this. So a lot of times for people who are building new applications in the cloud, they're going to embrace this kind of serverless, and then that'll help, with the total cost of ownership of running my software. The amount of administration we're doing starts to go way down because we're leaning on the cloud vendor for more than just running the physical data center. We're leaning on them to take care of my operating systems and the infrastructure to run this code. This kind of brings a good place to talk about what kinds of workloads are people running in the cloud. And why do we run into the cloud? Why might we run into multiple clouds? So what are people running in the cloud? Well, sometimes you find yourself using a particular public cloud just to host some sort of commercial off-the-shelf application, right? We bought this software and it runs in Azure, so we had to get Azure, right? But most people, when they say, hey, we're moving to the cloud, they're talking about we're going to run our own applications that we build in the cloud, and we got to choose which cloud, right? So a lot of times the first steps in that, after you do some pilots and stuff, is what we call a lift and shift, where you take existing apps that are sort of well suited for running in the cloud, and we take them as is and drop them into the cloud. Now, those existing apps are rarely designed to take care of all the benefits of the cloud, right? So they're not going to work well in serverless and things like that. They may not even scale the way the cloud can scale, right? So after a while, a lot of times at ExitCertified, we get people come and take, their first couple classes, and then 2 years later, they start saying, hey, we're starting to embrace this concept of cloud native, and we want to build our applications with containers and Kubernetes, because we think that will, take our big applications and split them into microservices, and then we can take advantage of some of the really interesting benefits that the cloud has. So when you hear people talk about cloud native, that's typically meaning that they're going to containerize their applications, embrace microservices, really build applications that take advantage of all the cloud has to offer, and maybe even be a little bit, ideally, a little bit portable between clouds even. That is one of the sort of benefits of going to that. So that's sort of another type of workload that we often see. There are some people who are really looking to take advantage of serverless architectures to eliminate a lot of that basic administration of VMs. Mm-hmm. And then the last big workload that we see in the cloud is once people are running applications in the cloud, you start to realize, hey, we're generating a lot of data, right? And we don't throw it away like we used to back in the 90s. My first couple jobs out of college, we would generate a lot of log files and we would hold on to them for 14 days in case something went wrong. We'd go look at them and then we threw them away because we didn't have good ways of querying them, because it was really, sort of semi-structured data didn't fit well into the rows and columns of a database. Well, these days we have a lot of much better ways to search through that semi-structured data. We don't throw anything away, especially because it's very cheap to store data in the cloud, right? All of our cloud storage comes down to, pennies per terabyte or pennies per gig per month. And then if, it's older data, we can hold on to it forever in really cold storage pretty cheaply. So once we have a bunch of these apps in the cloud, we're generating data in the cloud, we're starting to realize, hey, we got a lot of data there. And now that we have the right techniques to mine it, there's gold in that data, right? And so nowadays, everybody wants to be seen as making data-driven decisions, right? There's a big push from business leaders. They say, hey, I can't be seen as just making decisions based on a whim, right? I have to make data-driven decisions. So you need to get me that data so that I can, use it to make those decisions. And so, analytics in the cloud is really, really interesting because we've got the scale of the cloud, so we can work in parallel on massive amounts of data. And that means, things like traditional data warehouses, and these days we've got data lakes, and sort of somewhere in between, we've got lakehouse architectures, and it's a good place to store all of our data. And then we can do more interesting, machine learning, looking to the future and helping us make those decisions. And so that's a big part of what people do once they move to the cloud, is they realize, hey, we've got all this data, let's start using it. So those are some of the workloads that we see a lot in the cloud. Now, let's turn to the real business at hand in this presentation, which is let's look at we're going to mention the big four major providers. I mentioned AWS already. They were sort of the first and most popular. It came out in 2006, although a couple of the services predated that. That's when S3 and EC2 came out, and so that's when they sort of separated as another company. It is definitely the most popular and most mature platform. The two biggest competitors came out, like 4 and 5 years later, right? So Azure and Google Cloud. Azure is, I would say, definitely the second most popular. It is very popular if you're a Microsoft shop, if you're doing .NET development, SQL Server, all that stuff. You don't have a lot of Linux. Google Cloud, sometimes you'll hear people call it GCP. They used to call it Google Cloud Platform. It kind of made a big stink about calling it just Google Cloud now. It's very popular in a couple of different places, certainly machine learning and AI people. If you look, Google kind of created TensorFlow, so it's a good place to run TensorFlow type apps for sure. They also do good with Kubernetes because they created Kubernetes as well. IBM came out in 2010 with their own cloud. It used to be called Bluemix. It was popular enough if you're 100% an IBM shop. And, I worked at a place that was an IBM shop straight out of college. And, those days, you picked one vendor and you got everything from them, right? Like those days are long gone now for most companies, but there's a lot of companies that still have that legacy. And so IBM Cloud is still kind of in the mix, but it's not great for just general stuff. So we don't really include it in our conversation going forward. Now, Oracle Cloud was sort of the newest one. It came out in 2012. It wasn't super popular. They completely revamped it in 2018. And since then, they've got a few high-profile customers. And so people are starting to take another look at it. And they have some interesting advantages. So we'll include them in the mix, even though they are further down in popularity. If you look at what the industry thinks of these, probably the most recognizable source to go to is Gartner, right? And every year they put out this Magic Quadrant, which tells you who are the leaders in a particular space. And so this is the for cloud infrastructure and platform services. So again, IaaS and PaaS, right? And you see that AWS is up in the top right. It's the leader. But Microsoft and Google, you know, if you looked 6 years ago, AWS was the only one in that top right quadrant, right? But Microsoft and Google have gotten up there now, and Oracle is creeping up for sure. But you'll see Alibaba and Tencent and Huawei are in there. They're not big players in North America, so we don't cover those really. But you see that IBM is sort of being left behind. Microsoft has really moved up in this list, and the other place where you see Microsoft moving up is in market share. Obviously, AWS, you know, having a huge lead on the others because they came out so much earlier, they always enjoyed a good market share. But this was from just last year. This is Statista does this sort of survey every year, and they look and they estimate AWS at 34% of the market share. And then Azure at 21, Google Cloud at 11, Oracle's down at 2%, but it's, you know, it is starting to grow a little bit more than it has in the past. So Azure has gained quite a bit in the last 5 years, I would say. So that's sort of where the market is and when things came out. Let's do the actual comparison. Why would I pick one versus another? Right? So this is the bulk of what we want to talk about. Before we really get into comparing each of them on, you know, why would I pick one versus another, it's probably worth looking at what's their worldwide infrastructure look like? How do they how's their terminology differ? Just so we can then talk about comparing things maybe based on that. So we'll start with AWS. AWS has data centers clustered together in what they call AZs, or availability zones. So an availability zone could be just one data center, but it's usually a couple data centers right beside each other. And then miles away, they've got another cluster of data centers. And so, you know, close enough, you know, when we say that, you know, these data centers right beside each other, they look like one data center, right? And then two or more of these AZs within a few miles of one another, they call that a region, right? And they currently have 31 regions with 99 AZs. And if you want the current list, let me see this, I should be able to click on this and bring up my browser. So this is, you know, AWS, 31 launch regions, 99 availability zones, and 450 plus points of presence, right? So these are the regions you can see in North America. They've got 6 in the US, 1 in Canada right now, and another one coming soon in Western Canada. And the idea is, you know, you can use any of these regions. You set up an account, you can go launch things anywhere. Well, except there are 4 special ones. There's 2 in China, Beijing, and the newer one in Ningzhou. These ones, you have to fill out a form saying how and why you're doing business in China to be able to use those. Similarly, there's a couple in the US called GovCloud. So there's a GovCloud East and a GovCloud West. You have to fill out a form. They do a background check to make sure you're either a green card holder or a US citizen. And they really sort of, not all the services are available in those, only the ones that have been heavily vetted for things like ITAR compliance and certain levels of FedRAMP compliance. So if you want to run you know, Department of Defense stuff, you're going to have to run it there. But any of the other, 27 regions, right out of the box, I can use them, right? And so, here I've got a little account that I use. Here's my AWS one. And, right now I'm in Northern Virginia, but I can pull that down and I can use any of these other regions right out of the box. Oh, some of them are not enabled. I have to go and enable them because I've never done anything with them, right? But I can use them easily. I can go and enable them. Right? So that's the big idea. Now, when we talk about, 2 or more AZs make up a region, the idea is that they are, all the AZs that make up a region are within 100 miles of one another. They're usually around some sort of, city, near a city. The largest and oldest region is it's called US East 1. It's in Northern Virginia, just outside DC, kind of all those towns around Dulles Airport where a lot of tech happens. This one town will have a bunch of data centers, and then a few towns over, there's another bunch of data centers, close enough that they can put very high throughput between them, very low latency lines between them, so that I can easily replicate things from one AZ to another, but far enough apart that if some sort of local disaster takes out one, hopefully it doesn't affect another, right? And so AWS really tries to make sure that these things, are independent as much as possible, right? So they try and put them on different floodplains and different sides of fault lines, and even attach them to different electricity grids if possible. They certainly have separate backup, generators and everything else. So anything they can do so that if one AZ goes down and you're running things across multiple AZs, you're still okay because things are running in the other. Right? Now, the ultimate for high availability is to say, well, I'm going to run things in multiple regions. Right? If I'm a multinational company and I need to have these things running, even if, something disastrous happens in one country, I still need that infrastructure to be able to run somewhere else. So this is sort of the blueprint that a lot of the other cloud vendors have taken. So you'll see that Google Cloud and Oracle Cloud look very much like the AWS model, and the terminology very similar. Azure has slightly different terminology. So they also have the concept of regions. They have many regions, 60 plus. Many of those regions are also decomposed into multiple availability zones, although some regions can be as small as one data center, right? So you have to be really careful when you launch things in Azure to say, hey, is this region really, or like I'm more likely to end up becoming multi-region in Azure to get that high availability, right? Now, they do group the regions into something called a geography, right? So maybe all of the regions in the US are in one geography. They share the same data residency, sovereignty, compliance, resilience requirements kind of thing. And again, I got a link here if you want to find the most up-to-date infrastructure there. So I'll put these links into the chat if you want them, I guess. Yeah. I mentioned the Google Cloud, very similar to AWS. It's got 36 regions made up of 109 zones, very similar to AZ's. Google's very vocal about their network infrastructure, whereas the other providers, they don't mention it as much because Google, obviously, they move a lot of data across their backbone around the world. They have a lot of, fiber optic lines across the oceans and stuff. And so that is one of their big selling points, is like how vast and fast their network is. But what you'll find is that, all the vendors now have, either laid their own fiber or they're leasing long-term leases on fiber lines across the Pacific, so that they'll have a global network. But they tend to brag about it a lot because I think, they think, at least, and most people seem to agree, that they have a very good network. So that might be one of the reasons when we get to the advantages of each, that's sort of one of them. And then finally, I did mention Oracle Cloud Infrastructure, OCI. They have 41 regions. They're all made up of one or more availability domains. And then those availability domains contain 3 separate groupings of hardware and infrastructure. Could be in the same building, but you almost think of them as virtual data centers called fault domains. So many of their regions only have one availability domain, but they are still split into 3 fault domains. So they still do a very good job of high availability, but it's not quite the same extreme distance between those fault domains. So, kind of similar, and this is actually something that you'll learn, along the way. If I did this cloud comparison in 2012, you'd see that the services that they each offer are vastly different, right? And what happens over time is, somebody innovates and says, hey, we're going to go use machine learning to proactively look in your storage and look for, data that seems like it should be obfuscated and it isn't. Like, hey, I found these social security numbers that aren't obfuscated in any way, right? That could be a problem. It's probably a problem for compliance, right? And so we'll just red flag it. Hey, you should look at this. So Azure kind of came up with some of those, and then all of a sudden AWS has a service just like it, right? So this is what happens, is that they used to be very different in terms of the number of services and what kinds of services they offer, but they keep over time getting closer and closer and having very, very similar things. Having said that, at any point in time, there may be a new service that one of them has that the others don't, and that might be when you're trying to decide and you say, hey, that's a service we need, right? So that may tip the scales for one cloud provider over another. But if we take those apart and we just look overall at the services and what they offer, let's look at each cloud provider and decide, why would somebody pick AWS? Well, in a lot of ways, AWS is sort of the default choice because it's the most popular, right? It's the easiest to find somebody who it, right? Because it is very popular. A lot of kids use it in university and colleges. So new hires, they may already have some AWS knowledge, right? Certainly anybody who's out there in the industry has probably bumped up against it, right? So sometimes something is popular because it's popular, right? Anecdotally, over the last 8 years of me talking to students about various clouds, it seems to be the most reliable in terms of, like failures. According to a company called Cloud Harmony that tracks this, it seems to have the least amount of downtime of all the major public clouds. Of course, when there is downtime on AWS, it's a big deal because half the internet doesn't work, right? So there's been a few very high profile problems with AWS. One that I can think of last year, one in 2018, one in 2017, a big one back in 2012. But the fact that I remember all the major outages, tells me it's not a commonplace, right? So I think that they may have the least of these outages, but they are the most high profile ones when they happen. This, I would say, is kind of maybe my own opinion, but I think that AWS is the best in overall in breadth and depth of services. I think it's got the most mature and popular serverless options using Lambda, and they have 200 plus services, right? So when you look at the management console for AWS, I mean, if you're new to the cloud and you're looking at all these services, it's got to be daunting. You're like, how do I learn all this? Because I can tell you 10 years ago, when I first looked at the AWS console, there were 8 things in that list. And I said, okay, I can learn this. Now it's 200 plus. And you say, how am I going to learn all this? Well, the good news is you don't have to, right? Are you making robots? Well, then no. If you're not, you're probably never going to use RoboMaker. Are you launching satellites? No? Well, then you'll probably never use Ground Station, right? So there's a lot of niche PaaS offerings that you might never touch, right? But out of these 200 plus, there's probably, 12 to 20 that everybody uses, and another 15 to 20 that most people use, right? So if you come and take, a 3-day architecting on AWS class from ExitCertified, this is a class that's built by Amazon. They certify our instructors to teach it. So it is very much an official AWS class. These 3-day classes are usually the best introduction from a technical standpoint. We have like 1-day classes just for non-technical people, but you're going to learn those 30 services that you need to know. And then there's further classes for more niche ones if you're doing analytics or security or whatever, right? But when I look at Azure, hey, no, I don't have Azure here. I got Google Cloud here, but you'll see, hey, compute engine, we got lots of stuff, Kubernetes engine, storage, it goes on. And so we don't have that same list, but I can do a view all products and you'll get, a similar kind of very long list of services. And, same thing. I think I've got Oracle here as well. This is the dashboard. Let's close up some of this stuff. Here, I got to go to this hamburger. And again, compute, there's a bunch of stuff, storage, a bunch of stuff. All right. So you get the sense that, hey, they all have a lot of services, right? But I think that AWS has, literally the largest number, right? Now, I mentioned earlier why people would embrace Azure. Well, number one, sometimes it's the easiest route because you already have a relationship with Azure. You already have, or with Microsoft, sorry. You're already maybe using Office 365. So you've already got all of your employees set up as users, right? You've already got contracts and you're paying them already, right? So a lot of times it's just an easy transition to start using their cloud. I mentioned that if you are a Microsoft shop and you're doing all your development in .NET, great. They've got awesome PaaS offerings for that. It's the cheapest place to run Windows Server and SQL Server, right? Certainly much cheaper than AWS because you can leverage your existing licenses and things like that. Another thing that Azure does well is hybrid. We're going to talk a little bit about hybrid cloud, where you want to run some things in your own data centers and some things in the public cloud. Well, Azure has something called Azure Stack, where it's the hardware and software, you can run in your own data center, but you're running the exact same Azure services. Okay? Now, all the cloud vendors have something like this, but the Azure Stack seems to be very popular. In AWS, they have just a few of the services are available in their AWS outposts, right? So I can run certain types of storage and certain types of compute, but I can't get like those 200 plus services all in there, right? Whereas Azure, it offers a very big chunk of what they could do. Another thing that made Azure popular was that they had a presence in many countries before some of the others. And because I want to run certain workloads in my country, a lot of countries have data sovereignty laws that say, hey, this kind of financial data cannot leave Germany or whatever, right? That's why we have so many regions around the world now. At first, it was just, geographic disparity, right? If I'm going to run a web server in Northern Virginia and all my customers are in Osaka, Japan, the latency is going to become a problem, right? So I need to have data centers around the world. But why do we have so many in Europe? It's generally because of those data sovereignty laws, right? And Azure really was able to get into a lot of countries quickly, partially because their concept of a region was much smaller, right? But that actually got them a lot of traction with a lot of customers because of that. Now, what about the two lower placed offerings? Why would I pick Google Cloud? I mentioned earlier that Google Cloud is very popular if you're really heavily into machine learning and AI, right? Google has a lot of experience in running things, especially TensorFlow, because they built and developed that, did a lot of research on it. So they do a really good job of running those things. Not that you can't run TensorFlow or any other, ML framework in other clouds, but it's just, they do a great job of housing it for you in Google Cloud. So some people, I've even seen customers where, they are basically an AWS shop. Everything runs in AWS, and then they take all their data and move it to Google Cloud to do their machine learning there, because they found that it works better for that group, right? Another thing that Google sort of championed was the idea of Kubernetes. And Kubernetes is built, it's an open source project. Anybody can, build it and develop on it. But it was started in an internal project at Google called Borg. And turns out that, they've been using it internally for many, many years. So they know how to run it really well. And so if you want to run Kubernetes workloads in Google Cloud, they have something called GKE, the Google Kubernetes Engine. It's very cheap, it's very up to date, it's very fast and easy to use compared to some of the other similar services. So Azure has AKS, Azure Kubernetes Service. AWS has EKS, the Elastic Kubernetes Service. They all have something, because Kubernetes has become very, very popular, but it's a bit of a pain to manage that framework, right? So the cloud vendor says, we'll take care of the control plane, you just worry about the data plane. And it seems most people find GKE the easiest of those to use and the fastest. Finally, I guess it's probably worth mentioning, Google Cloud leverages Google's incredible global network. They also do some interesting things because of that global network. When you create a network, a VPC, right? In most of the clouds, VPC stands for Virtual Private Cloud. That's your slice of the cloud vendor's network where you're completely in charge of the networking and stuff. With AWS, that has to live with just one region. So if I want to run things in multiple regions, I have multiple VPCs, which isn't a problem. But if they need to talk to one another, I have to set up peering, and there's some things you need to do. With Google Cloud, you can set up a VPC is a global thing, and I can set global load balancers that will send traffic to one region or another, and I don't have to get involved in DNS. They allow me to do it without an extra level. So they do some interesting things with networking, pricing. Google Cloud, this one's very hard to compare, right? When you look, every cloud vendor has sort of a set pricing that's available, right? Here's how much this costs per hour. Here's how much this costs per, gig of storage per month. That's typically how, compute and storage are calculated. But the problem is, if you're a very large consumer, say you're Netflix and you're storing 60 petabytes of content in Amazon S3, are you paying the retail rate? There's no way, right? So most large customers will have some sort of an enterprise plan agreement where they say, hey, we're committed to spending so many millions a year, give us, some sort of discount on these services. So it's very hard to compare pricing, but you can compare the public pricing of things. And Google Cloud tends to have the cheapest for compute and storage compared to certainly Azure and AWS. OCI is pretty cheap as well, but probably the number one reason somebody will pick Oracle Cloud is because they are Oracle customers, right? So they're running Oracle databases, Oracle applications, Exadata, which is sort of that data warehouse appliance, Oracle real application clusters, right? Doesn't mean you can't run Oracle in other clouds. AWS, for example, you can run Oracle in RDS, but it's much cheaper to run it in OCI. Oracle RAC, you can't really run in any of the other clouds. Other cloud vendors, you can run certain Oracle software, but you may have to pay for bare metal servers. And by the way, bare metal servers weren't really available everywhere. Oracle was the first of the clouds to offer that kind of concept. Another reason some customers, and again, their market share is small, but you may have heard of some high profile customers like TikTok and Zoom even, that have chosen OCI, maybe not as their only cloud vendor, but one of the ones that they're using. That's typically because of their egress pricing. in pretty much all the clouds, you pay when you move money, when you move data out of the cloud, right? So often, if you're going to move data into the cloud, it doesn't cost money to move ingress. But when you grab large files and you download them from the cloud into your own data center, that's going to cost you a lot of money, and or across the internet, right? And so Oracle's egress pricing is by far the lowest. And so you can imagine somebody like Zoom, who all they're doing is, pushing video across the network, across the internet, that's a big reason why they might like this, right? Oracle also has some SLAs, so service level agreements. All the cloud vendors have some sort of SLAs around how available is the service. OCI also has some SLAs for manageability and performance. So if you don't get the performance that you're supposed to, you get a credit on your next month's bill, right? So that should keep them honest on some of these things. And I mentioned that they were first with the bare metal. They still have the largest bare metal service allowed, if that's what you're looking for. That means you're not running a VM, where there's some sort of hypervisor running somewhere taking care of some. I'm just getting that bare metal server. Now, what Oracle has sort of recognized, especially when they did their relaunch in 2018, they realized, hey, we're a small market player. Google understands that too. And so both Oracle and Google, when you look at their marketing, they're really saying, hey, everybody's got to be multi-cloud these days. Whereas when you look at Amazon, they're saying multi-cloud, no. If you go to multiple clouds, all you're doing is, I'm spending some money with this company and some money with that company. I've got less bargaining power then, right? So the marketing's different when you're the market leader versus somebody trying to chip away at the market, right? And so one of the things Oracle realized is they said, well, there's a lot of people out there using Azure already, but because they want to use certain Oracle databases, let's let them run the databases in OCI and run the rest of their infrastructure in Azure, and we'll play nicely, right? So they play really nicely with Azure. You can run your application tier in Azure and your database in OCI using something called Oracle Database Service for Azure. And so they've got, in various regions, nice, easy ways to connect and move your data back and forth where you're not going to get really hit on the price badly, right? So this speaks to sort of this idea that, multi-cloud architectures are coming, if you're not there already. So it's worth taking a quick look at hybrid and multi-cloud. So hybrid is the idea that you're using more than one cloud, but one of them is probably a private cloud. So you have some things in your own data center and some things in the public cloud. Now, this is from last year's Flexera State of the Cloud report. And they said, well, hey, we've got a lot of people that are using some sort of multi-cloud, but most of it is really the multiple clouds are, one private cloud and one public cloud. There's actually not that many companies actually doing multiple public clouds, running workloads across many of them. There's lots of people just in a single private or in a single public cloud, but hybrid is really big, right? And so let's talk about hybrid, and then we'll talk a little bit about multi-cloud. So hybrid, it's an easy way to ease into the use of public cloud, right? You've already got all your own data centers. You're not just going to get rid of them right away, right? So you're going to leverage that existing data center investment, but maybe start new apps in the cloud, or use the public cloud just for what some people call cloud bursting, right? I remember ExitCertified, we started using Zoom for our virtual classes way back when they first came out in 2014. And at first they had only their own data centers. Then they told us, hey, we're starting to use AWS in case things go wrong, or in case things get very popular and we start to run out of room, we can run those exact same workloads that we run in our own data center in AWS. And we said, great, then pandemic came and everybody started using Zoom. And now they use all kinds of clouds, right? Just so that they're not even just in one cloud vendor, right? But that idea of cloud bursting is where you say, hey, we're going to use the public cloud for when things get really busy. Okay? Increasingly, customers want to use multiple public cloud vendors, but it's often to take advantage of the sweet spots that each provider does best, right? You might say, well, I've got this external application that I bought and it runs on Azure. So we've got Azure for that, but we have other stuff in AWS, or maybe we're running AWS, but we're doing some analytics in Google Cloud because of the machine learning frameworks that we like, right? So there might be that. What we find is that there's very few organizations that are trying to run the exact same workload in multiple public clouds and say, hey, we're going to go wherever it's cheapest to run this workload, or wherever, I don't know, if something goes wrong here, we can run it somewhere else. The problem with that is that you have to make your application kind of the lowest common denominator, right? You can't use any of the good bells and whistles of each cloud provider if you're trying to make it generic to run everywhere, right? Now, there are some tools and frameworks that can help us with that, right? One of the big ones is Red Hat's OpenShift. Right? And we're partnered with Red Hat, so we do OpenShift training as well. And so for a lot of large companies, this is very attractive. And so, what you're really doing is you're saying some of the PaaS offerings that the cloud would normally provide, the framework will provide. So I take this OpenShift thing and I can run it in any cloud, and it kind of runs the exact same. Right? Even just Kubernetes, to a certain degree, shields you a little bit from that. But OpenShift says, hey, we're going to take Kubernetes and we're going to make some very, specific opinions about how that should run, so that it runs in a nice way. So, that idea of multi-cloud, I heard a lot of last time I went to one of the big conferences, I went to reInvent in November, which is AWS's annual conference. When customers start talking, they say, we're multi-cloud, but we mainly use AWS. And I was like, okay, what do they really mean when they say we're multi-cloud? Does it mean we can run the exact same workload in multiple clouds? Because most people, that's not the case. It's that they're running some things in some workloads in one cloud and some workloads in another. But if you want to avoid, lock-in, then you don't use all the bells and whistles that the cloud provider runs, and then you can be, free to move between them, if that's important to you, right? Now, moving to the cloud is very rarely just, hey, I'm going to let Amazon run my data center or Microsoft. There's a lot that goes into a cloud journey. Okay? Most organizations, when they embrace cloud, they're kind of doing three things at once. First off, they're embracing a public cloud provider, usually one to start. They're often saying, well, when we move to the cloud, let's further embrace DevOps culture and tools, because what we find is that some of the DevOps ideas of automating all the steps when I check code in and going and launching a production-like environment to run all my tests and then get rid of it, all that works nicely in the cloud. And we're going to take our big monolithic applications and carve them up into hundreds or thousands of little microservices so that I can deploy them independently and I can scale them independently. And there's some really nice things that come out of that, right? And so if you really want to move to the cloud and take advantage of everything the cloud has to offer, you might have to learn a lot of different new skills and technologies. And so at ExitCertified, we came up with this diagram just to sort of show a picture of what we are doing these days. At the center of it is authorized training from your public cloud provider. And we're partnered with the big four. We do the authorized training for all of them. I personally don't do the Azure training. We got a couple colleagues that do that. But I do teach AWS classes and sometimes Google Cloud and Oracle Cloud. But, they don't teach you everything, right? They are very focused on their own technologies. If you do want to embrace the idea of cloud native, and you got to learn about containers and Docker and Kubernetes and even the concept of microservices architectures, we got a bunch of classes on that, right? And one of the things we find is that there is no vendor of note for microservices architecture. So we got to find what's the best material out there. And so that's a big part of what we do, is go and find, who's got the best Kubernetes training. And we sort of landed on two different vendors, right? One that we think just does a great job of training. Mirantis is a cloud native company. They know a lot about containers and Kubernetes, and they built really good training that is vanilla. It's not, from some vendor saying you should use Amazon's EKS, you should use Google's GKE, right? It just teaches you the basics of Kubernetes. The other one we have is a little more geared towards the Cloud Native Compute Foundation's various certifications, the CKA, the CKAD. They've got a few Kubernetes certifications, and so we've got some classes that really align nicely with those. Right? But if you go around the horn, there's a lot of stuff in here. When it comes to programming, there's a lot more stuff than we could fit in this diagram. Those are just some of the more popular training that we run into these days. When it comes to analytics, you might just need to learn some basics of, hey, I need to learn, well, maybe I first learned Python, then I learned Python for data science, and then some heavier machine learning stuff. I might take some machine learning classes from the public cloud vendor, but then we might also have things like, our BI tools like Tableau and Cognos and Power BI, all those things. And then there's other analytics vendors like Cloudera and Databricks, and we've partnered with all those to offer their training as well. So this is, we have a CloudCentrics a page on our website, which maybe I'll find that. Does this take me to CloudCentrics? Yeah. Here, I'll just throw that in the chat so you can copy it if you're looking for this diagram to play with. If you do go and download that diagram, each section, when you click on it, takes us to a part of our website where you can read more about that. Couple things just to end off. We're at the top of the hour. I've been looking. I haven't seen a lot of questions. It's good time to start putting them in because I'm going to get to those. I have the links here for each of our training courses. Actually, maybe I'll put those into the chat as well. And the other thing that we have coming up at the beginning of May, we've got our Cloud Plus Skills Summit. This is a free 3-day virtual event. It targets both technical people. We have some technical sessions. If you are familiar with one of these clouds and you want to learn the other ones, we've got probably a 3-hour session on AWS, another 3-hour session on Oracle Cloud. For Azure, we're offering a 1-day Azure intro class, so the AZ 900 class for free. For Google Cloud, we also have a 1-day fundamentals class for free. So those are part of this event. So if you go and register for that, actually, let me put we've got a shorter URL that doesn't look as nasty. Let me find it. ExitCertified /
Oh, Miles, I just posted that to the chat.
Oh, you put it in. Okay, perfect. Yeah. Thanks. Yeah, that's much better. So that's the Cloud Summit. So it's free. You just go set yourself up, and when it comes time, you can go and pick which of these things. So there's some actual training. Like I said, this is a full day class, 9:30 to 4:30 Eastern, for the Microsoft Azure fundamentals. And I don't know, Thursday is the last day, and that's the one where we have the Google Cloud fundamentals 9 to 5 class. We also have a security and compliance Microsoft SC 900 class on Thursday as well. So there's some good stuff in there. Every day we'll have like a short keynote in the morning. There's also some classes that are a little bit more geared towards the learning and development people. And yes, it is all free. The entire summit is free. So any of that stuff is free. So that's why I bring it up. It's a month away, but it's good to see it. 3 weeks away, I guess, maybe. Oh, yeah, I was going to grab these links and put them in as well. How can I do that? I might have to end my slideshow to do it. So are there any questions while we're waiting? Where did my chat go? Throw them in the chat now. There we go. That seemed to work. Oh, by the way, I should probably throw my email address. I'll just put it into the chat. Sometimes you don't think about it until a little later. You say, oh, I wish I would have asked this question. Fire any of those kind of questions to me after the fact. Can I talk a little bit about Ansible, Michael says. Yeah, for sure. So if you look in our diagram here, under automation, I've included a few things in automation. Automation is kind of a very broad topic. These four, logos here, these have to do with infrastructure as code. And so, Puppet and Chef, you might have heard of, they've been around for a very long time. Long before the cloud, people were saying, hey, I've got 10 Linux boxes and I need to make a change to all 10 of them. So I can remote into each one individually. That's a lot of work. And what if I forget to do one, right? I mean, anything manual is now considered kind of a security problem, right? So the idea with Puppet and Chef is you generally set up some sort of server and you'd say, hey, I want to make this change. And then that would push out to all the servers, right? And so those became very popular for larger organizations that had, say I've got 20 web servers and I need to make changes to them. I make the change on the Chef server, and then all those other web servers are heart beating in saying, hey, has anything changed? Anything changed? Well, when we move to the cloud, what we'll find is that we can use that same concept, but not just what's installed on this Linux machine, because everything we do in the cloud is an API call, setting up that virtual network, right? Launching a server, setting up an auto-scaling group of a bunch of web servers, right? And so everything from the setup, everything. And so Ansible kind of came around at the right time where they said, we can do what Puppet and Chef did, but we can also, instead of just saying what goes on this virtual machine, the actual launching of the virtual machine and the network in which it goes and all that cloud infrastructure, we can do all of that. And sometimes you hear these tools called IAC, like capital I, little a, capital C, infrastructure as code. And the idea is we'll treat that infrastructure, these scripts that we build, just like developers treat code, meaning we'll check it into a code repository, right? Because, that's how most people do development, right? You got a bunch of programmers, they check code into a code repository. Why? So that, if they make a change, they don't want it to blow away their colleagues' changes to that same code base. So we can see who made a change, when did things get, we don't stomp on each other's changes. If something goes wrong, I can roll back to the last one. Well, now we can do the exact same thing with our infrastructure, right? We treat it just like code. We check it into, we can look and say, hey, what's our current infrastructure look like? If something goes wrong with it, we can roll back to the last known good one, right? And so that's the big idea with Ansible. Now, Terraform is another one that goes a little further and says, hey, every one of these four cloud vendors has their own way of, saying, hey, I want to create a network and launch this auto scaling group and all this stuff. But then I have to learn CloudFormation to do it in AWS. I have to learn ARM to do it in Azure. I have to learn, so on and so on. And so Terraform is just a nice vendor agnostic way that I can use the same template way no matter what cloud we're in. So that's where those automation tools come in. Got a question here. At a high level, is there any big difference between Docker and Kubernetes? Yeah, for sure. So Docker is really just about the concept of making containers, right? And it's like a very lightweight container that is, when you compare it to a VM, I can run many Docker containers in one physical machine or one virtual machine. And there's really good things that come out of that. But if I'm really going to take a huge application and split it up into hundreds or even thousands of microservices, and every one of those is a Docker container, then I run into a problem of just trying to orchestrate how to deal with all these containers. And so the Docker containers themselves, those are great, but I need a way of orchestrating them. Now, Docker came up with an idea, and so they have a tool called Docker Swarm. And so that got kind of popular. There were some other alternatives, but at Google, they created Kubernetes. And pretty quickly, the whole industry went, yes, we like that more. And so Kubernetes is the way of orchestrating all these containers. They could be Docker containers, or now there's some other alternatives to Docker, but you're going to use containers within Kubernetes. So that's the sort of relationship between them. Paul asks, I wonder if I missed any other questions before that. No, Taco Tuesday, yep. What is meant by hybrid cloud vendors in the top left of the chart versus public cloud vendors? Yeah, so if we look in here, things like VMware, right? You can imagine VMware can be used to set up a private cloud in your own data center, but it also has VMware Cloud, and I can run VMware Cloud on AWS or on Azure, so that I'm using the exact same tools from the same pane of glass. I can decide, should this workload run on a VM on my own data center, or should I run it in the cloud, right? So it's very much a hybrid kind of tool. OpenShift, I mentioned, is a framework for providing, PaaS kind of services to these containerized applications, and then I can run it on-prem or in any cloud, and it runs the same way. So a lot of those have to do with that kind of, hey, Veeam and NetApp, these all have to do with, hey, I've got infrastructure somewhere, whether it's in the cloud or on-prem, and I need to back it up. I need to, do whatever with it. And so that's why we kind of consider those sort of hybrid cloud or private. IBM Cloud, I guess you could put in public cloud, but I guess the courses that we run are mostly about hybrid stuff with IBM Cloud. I guess that's why we put it there. That one, you could make an argument that it should be in public cloud. Yeah. All right. The chat will not allow me to copy and paste. Ooh. Put all the details in one slide, including the recording. You know what? Yeah, the recording, the PowerPoint is all hyperlinked. So I think I can make a PDF of that, and I'll make sure that that gets sent along with the recording. Yeah, I think that's the way to do it. So I'll get that PDF to our marketing folks, and they'll send that along with the recording. All right, so I think that's probably, I think I'm probably going to redo this presentation again during our, I think we've got that included as one of our sessions in that Cloud Plus Skills Summit. So I'll have to keep it just under an hour. So yeah, I went 8 minutes over today with the questions, but hopefully, I think we've lost a few people, but not too many. All right, well, good luck, and we hope to see you in a class. If you have any questions, you got my email, Miles at ExitCertified, or miles.brown, Miles with a Y, at ExitCertified.com. All right. I'm going to stop share and stop the recording.